Hello and welcome to LM Reads. I'm a researcher who loves to break down fascinating books for you. Today, we're diving into a book that is, and I don't say this lightly, absolutely foundational. Deep Learning with Python by none other than François Chollet, the creator of the Keras library. And let me tell you, this book is special. It's not just some dry, technical manual. It's your guide to understanding one of the most transformative technologies of our lifetime.
This quote right here just nails it. It really captures the sheer speed of this revolution. We're not talking about some far-off sci-fi future. We're talking about right now. In just a few short years, deep learning went from this niche academic thing to the engine behind tools you and I use every single day. Like when Google Photos finds your dog in every picture, or when Amazon just knows what you want to buy next. This book's whole goal is to demystify that incredible leap and show you how to be a part of it. So, let's start with the big question. What is deep learning, really? Before we get into the nuts and bolts, it really helps to see the big picture. Think of it as the super powerful, specific technique that's fueling this massive explosion we're all seeing in artificial intelligence right now. To really get it, you gotta look at where it came from. The journey kicks off way back in the 50s with the basic dream of AI, getting computers to think. Then, fast forward to the 80s, and the field gets a lot smarter with machine learning. The big shift was from writing tons of hard-coded if-then rules to just letting the programs learn directly from data. And then, in the 2010s, everything changed. Deep learning arrived and just supercharged the whole process by learning through successive layers.
And that word, layers, that's the key to the whole shebang. Think of it like this. Instead of trying to solve a really complex problem all at once, a deep learning model breaks it down into baby steps. Each layer learns one simple thing about the data, then passes its little piece of wisdom to the next layer, which adds its own insight. It's this gradual, step-by-step process that gives deep learning its almost magical power.
Okay, I know that might still sound a bit abstract, but this is where the book is just brilliant because it gives us this perfect analogy that makes everything click. It asks us to think about deep learning as the simple act of uncrumpling a paper ball. I want you to picture this. Imagine you have a bunch of data from two different groups. Let's say pictures of cats and pictures of dogs. In its raw, messy, real-world form, that data is like two sheets of paper. One red one for cats, one blue one for dogs, that have been crumpled up together into a tight, messy ball. There's just no way you could draw a straight line to separate the red points from the blue points, right? It's a total mess. And this is exactly what a deep neural network does. It uncrumples the paper ball. Each layer in the network applies just one tiny, simple transformation to the data. It's like one gentle tug on the paper. It's not trying to do everything at once. But after a deep stack of these simple little tugs, the paper ball is completely flattened out, and now the cat pictures and the dog pictures are perfectly easy to separate. That's it. That's the core intuition of deep learning. It's just so elegant.
So the next logical question is, how does the network know which little tugs to apply? How does it know where to pull and smooth out the paper? Well, it learns. It learns through a process of trial and error, all powered by this beautiful, simple optimization loop.
This whole process is basically a four-step dance that just repeats over and over. First, the model takes a guess. Second, it measures how wrong that guess was. We call that error the loss. Third, and this is the really clever part, it works backward to figure out exactly which of its internal settings or weights were most responsible for the mistake. And finally, it adjusts those settings just a tiny bit to make a slightly better guess next time. It does this loop thousands, even millions of times, getting a little less wrong with every single cycle.
And this image is the perfect way to picture that learning process. The algorithm that does this is called gradient descent, and it works just like a ball rolling down a hill. The landscape, the hills and valleys, represents all the possible errors the model could make. The ball is just naturally going to roll towards the lowest point, the bottom of the valley, where the model is the most accurate. This simple, intuitive idea of rolling downhill is the engine that drives almost all of deep learning.
Okay, so we have the core idea, uncrumpling the paper ball, and we have the learning mechanism, the ball rolling down the hill. So how do you actually get your hands dirty and build this stuff? This is where the book introduces you to the actual accessible tools of the trade. The entire book is built around Keras, which makes sense because Chollet himself created it. And its philosophy is amazing. It's an API designed for human beings, not for machines. The goal is to be so intuitive and so simple that you can focus on your actual problem, the creative part, not on writing pages and pages of confusing code. And because it's built right on top of TensorFlow, you're getting all the power of Google's industrial-strength platform underneath.
And you know what the best part is? You don't need a $10,000 supercomputer to get started. The book shows you how to use free tools like Google Colab, which gives you access to a powerful GPU right inside your web browser. This is a total game changer. It makes deep learning accessible to literally anyone with an internet connection.
And this is where it all comes together. This is the payoff. With that core intuition and the right tools in your hands, the book walks you through building some truly mind-blowing and even creative applications. You'll start with a really practical task like this: image segmentation. Now look closely. Notice how the model isn't just drawing a box around the dog and saying dog. It's outlining the exact pixels that belong to the dog. That shows a much, much deeper, more granular understanding of what's actually in the picture.
And then things get weird and awesome. You learn to implement Deep Dream, the famous algorithm that produces these wild, psychedelic, almost dreamlike images by finding and amplifying patterns that the neural network has already learned to recognize. It's like asking the AI what it's dreaming about.
And finally, you get to explore generative models like GANs, which can create shockingly realistic, entirely new images totally from scratch. And just to be clear, these are not just photoshopped pictures. This is the AI generating a completely novel image, a face of a person who does not exist, based purely on what it's learned about what faces look like. It's incredible. So you go on this amazing journey. You start with a simple, beautiful idea about uncrumpling a paper ball, and you end up building tools that have what feels like a genuine spark of creativity. So, after all that, what is the final verdict on this guide to the AI revolution? I absolutely love this quote from the book because it's so honest. Deep learning isn't some kind of magic. It's a practical, messy, fast-moving field of engineering. And the real value of this book is that it cuts through all the hype, all the unreliable narratives, and gives you the solid, intuitive foundations and the hands-on skills you actually need to do good work. So is this book worth your time? My answer is a resounding 100% yes. If you are looking for a guide that perfectly balances intuition, theory, and real, hands-on practice, this is arguably the single best place to start your deep learning journey. It doesn't just show you what code to type, it builds a deep, lasting understanding from the ground up, it makes complex ideas feel simple, and powerful tools feel completely accessible. Have you ever looked at deep learning and thought, that looks amazing, but I wouldn't even know where to start? All the math, all the theory? It can feel pretty intimidating. Well, today we're diving into a book that basically throws all that intimidation out the window. It's called Deep Learning with Python, and it's written by François Chollet, the guy who actually created Keras. We're going to see exactly how this book makes one of the most powerful fields in tech accessible to pretty much everyone. So let's start with the big question. What is deep learning really? I mean, we hear about it all the time. It powers everything from the photo app on your phone to self-driving cars. This book tackles that question right from page 1, but not with a bunch of crazy equations. It starts with a simple, really powerful intuition. Okay, so let's get right into the book's foundational idea. The author argues that to really get deep learning, you have to forget all the hype you've heard about it being some kind of magical, artificial brain. The reality is actually way more elegant and, way more understandable. And here it is. This is the core philosophy of the whole book. Deep learning isn't magic, it's geometry. Just think about it like this. It's a method for taking messy, tangled-up data and just changing its shape. You apply one simple geometric transformation after another until that messy data becomes neat and organized. The book gives this brilliant analogy that I just love. Imagine your data is a crumpled-up paper ball. You've got red dots on one part of the paper and blue dots on another. But since it's all crumpled, they're completely mixed up. Well, a deep learning model is basically a machine that learns the exact sequence of moves to uncrumple that paper ball. It smooths it out step by step until it's flat again, and all the red dots are on one side and all the blue dots are on the other. Bam, separable. It's such a great mental model that makes the whole thing feel intuitive right from the start. So how does this uncrumpling actually work in practice? Well, the book breaks down the engine of deep learning into its simplest parts, and it starts with the most fundamental thing of all, the data itself. So everything in deep learning, and I mean everything, from your input image to the model's internal parameters, is stored in these things called tensors. And the book makes it super clear. Don't get scared by the fancy name. A tensor is just a container for numbers. It's basically a multidimensional array. A single number, that's a 0D tensor. A list of numbers, or a vector, that's a 1D tensor. A spreadsheet or a matrix,
a 2D tensor, and so on. It's the Lego brick that everything else is built from. And how does a model figure out the right way to uncrumple the data? It all happens inside something called a training loop. The book lays it out in this really simple 4-step process. First, you grab some data. Second, you run it through the model and get a prediction. Third, you measure how wrong that prediction was. That's called the loss. And fourth, this is the magic part. You adjust the model's settings just a tiny bit to make that error smaller. You just repeat this loop thousands, maybe millions of times. And with each cycle, the model gets a little bit better at its job. And this visual really gets to the heart of how the model knows which way to adjust itself. The process is called gradient descent, and the book explains it as being just like rolling a ball downhill. Imagine that the model's error, or its loss, creates this huge, complex landscape. Your goal is to get to the very lowest point, the bottom of the valley. Gradient descent is just the process of always taking a step in the steepest downward direction. With every step in that training loop, you roll a little further down the hill, getting closer and closer to the point of minimum error.
Okay, so we've got the concepts down. We understand tensors and training loops, but how do we actually, do any of this? The book's answer is a fantastic library called Keras, which, again, the author himself created.
I love this quote from the book because it just perfectly sums up the whole philosophy. Keras is designed for humans, not machines. It's all about being straightforward and easy to understand, so you can focus on building your model and solving your problem, not on fighting with complicated code. And this is so crucial. The book pairs every single concept it introduces with a hands-on Keras example. It's all about learning by building. You don't just read about what a dense layer is, you immediately fire up some code, add one to your model using Keras, and see what it does. This practical, hands-on approach is really what makes the knowledge stick. And we're not just talking about building little toy examples here. The book walks you through some seriously state-of-the-art applications. It shows you how all those simple building blocks can be combined to do some truly incredible things. Let's actually take a look at some of them. So for example, you'll go way beyond just classifying an image as a cat or a dog. The book teaches you how to do what's called image segmentation. This is where you build a model that can actually outline the exact pixels that belong to an object in a photo. It's a much deeper level of visual understanding. And here's something really cool. The book teaches you not to treat your models like a black box. You learn techniques to actually see what your model is thinking. What you're looking at here are heat maps generated by a technique called GradCam. It shows you which parts of an image the model was paying attention to when it made its decision. This is absolutely critical for debugging and trusting your models. But it doesn't stop at just analyzing data. You learn how to create with it. The book dives into the world of generative AI, teaching you how to build models that can produce original content. You learn to implement things like Deep Dream, which can generate these wild, surreal, almost psychedelic images. This is where deep learning starts to feel like a creative tool, not just an analytical one. And the book doesn't shy away from the absolute cutting edge. It gives you a full breakdown of the transformer architecture. The model that completely changed the game for natural language processing and powers all the big language models we see today. Yeah, that one. You don't just learn what it is, you learn how to build one yourself for tasks like machine translation. It's amazing stuff. So, after covering all these powerful concepts and walking through these really practical projects, we have to ask, who is this book actually for? Is it the right place for you to start your deep learning journey? Honestly, my verdict is that this book is an absolutely fantastic resource for almost anyone interested in this field. Its number one strength is that intuition-first approach. It builds your understanding on solid, relatable ideas before ever getting into the weeds. It is intensely practical. You learn by doing with clean, simple Keras code every step of the way. And even though it's super accessible, it covers modern, truly state-of-the-art techniques. It's perfect for software developers, students, or really anyone who knows a bit of Python and is curious about this technology that's changing the world. So that's our look at deep learning with Python. It really does an incredible job of demystifying a super complex field and turning it into something you feel like you can start building with, like today. Let me know in the comments if this makes you want to pick up the book.